Alright, let's turn our focus to the Poisson distribution. It's French. It's kind of easy. Yeah, 3 conditions must be met for a distribution to be Poisson. Why are you saying it like that? Because it's fun, and you're probably going to mimic me too. Here we go. The first thing that needs to happen is x needs to be a discrete random variable. Alright? The next thing that needs to happen is the occurrences are random, meaning that they can happen at any time. Next, the occurrences are independent of each other, meaning that if an occurrence happens, it doesn't affect another occurrence. To calculate the probability of an event occurring, we use this formula. According to the Poisson probability distribution, the probability of x occurrences in an interval is given by the formula p of x is equal to lambda to the x, e to the minus lambda divided by x factorial, where lambda, pronounced lambda, is the mean number of occurrences in an interval, and the value of e is approximately 2.71828. Here, the parameter is lambda. Lambda is the mean number of occurrences in that interval, or the average expected value. It's however many you would expect in an interval. Let's use that formula to calculate a couple of probabilities. Let's go to the board. Finding probabilities using the Poisson formula. Here we go. We should press on. We're using this guy. P of x is lambda to the x, e to the minus lambda divided by x factorial. So we go dot up, do, and we look at this guy. Lambda's 3. The average occurrence in this interval is 3 times. We want to know the probability that it is less than 2. So here we go. The probability that something is less than 2 is the probability that it is 0 plus the probability that there are 1 occurrences plus the probability of 2? No, because it's strictly less than. So this is going to be, I'm using that formula, lambda is 3 to the x, which is 0, times e to the minus 3 divided by 0 factorial plus, my lambda is 3, my x is 1 this time, because I'm putting the formula for this, to the 1, e to the minus lambda, which is 3, divided by 1 factorial, and then we pound both those out. And we find that this one is 0.0498. I did it in my head. It's written over there. Plus 0.1494, and then what do? Add them, and we add them, and we get 0.1992. So there's almost a 20% chance that you get less than 2 occurrences when you usually get 3 using this Poisson distribution. And then, how about we do a great example? When x is 8 example. Here we've changed our lambda to be 5.5. So we're going and we're going to go and we're going to find the probability that x is equal to 8. Great. Which is the same thing as p of 8. Great. So what are we going to do? We're going to go through and we're going to replace our lambda everywhere we see a lambda. 5.5 to the, my x is 8. Great. And then this is e to the minus, wait for it, 5.5 divided by 8 factorial. So then we pound all that out. We put it in our calculators, and we're going to find that this is going to be, 0.084871. Let's see if that makes sense. 8% chance of it being exactly 8 occurrences when we usually get 5.5 occurrences? Sure, the chances are small, but we'd expect them to be 5.